Today we're going to learn about the second derivative test. This is another way to find relative maximum and minimum points. If you love it, you can use it for most problems. I don't usually use it unless it's a scenario where they've limited the information that you have where you have to use the second derivative test. And I'll show you a few places where that happens. So what we have been using so far is called the first derivative test, which is where to find relative maximum or minimum points, we take the first derivative, we find the critical points, and then we do a sign line to tell whether or not we have a maximum or minimum point. So the second derivative test, for it, what you're going to do is you are going to look at the first derivative and find where it equals 0. So this means that you already have to find the first derivative and find critical points, right? So if you're already gone that far, I just assume do a sign line most of the time. But another option for this is you can think about what the second derivative is, because if the second derivative at that critical point is positive or is greater than 0, then if the second derivative is positive, what does it tell us? F is concave up, right? So we learned about concavity yesterday. So if you have a horizontal tangent and your graph is concave up, that means you're looking at something like this. It's concave up, horizontal tangent. What do you have? That is a minimum at that point, right? It is a little bit, kids get mixed up sometimes because the second derivative is positive and it is a minimum, which makes, positive makes me think maximum instead of minimum. But, so you got to think through it that way. I usually draw like a little tiny picture if I'm getting confused. If your second derivative is negative, then that tells you your graph is concave down. And if you also have a derivative that is horizontal, or a tangent line that is horizontal at that point, then you have a maximum point there. So rather than doing a sign line, you could just find the second derivative and look at its sign at those points. The reason that I don't love doing it is this last one right here that tells us if the second derivative equals 0, this test fails and you're going to have to use the first derivative test anyway. So it is possible that you work through and find the second derivative and you plug it back in and you get 0, which means you're going to have to go back and do a sign line all over again. So, so I don't usually use second derivative test unless I have to, but you definitely can use it for almost all problems. So if we look at example 1, we could definitely use first derivative test for this. First derivative test would work. But let's see what it looks like with the second derivative test. So whenever you are finding the relative extrema of this function using the second derivative test, you first have to take the first derivative and find the critical points. So f prime of x here is just going to be 2x minus 6. And then we need critical points, so we're going to set that equal to 0. So 2x equals 6 and x equals 3. So the first part of it is just like it is for the first derivative test. But now, rather than doing a sign line, we want to take the second derivative. Now, in this case, it's not a bad option because this is an easy second derivative, right? What is our second derivative in this case? It's just 2. All right, so then you are going to test critical points, which in this case, we only have one critical point. So we're finding f double prime of 3, and that is just going to give us 2 because there's nowhere to plug in a variable anywhere. So we just get 2, which is positive, right? So if the second derivative is positive, that tells us that we're concave up. We also have a first derivative that is 0, so we're looking at a minimum point. So to summarize that, you would say since f prime of 3 equals 0 and f double prime of 3 is greater than 0, f has a relative minimum at x equals 3. Okay, here. All right, I want you guys to try the next one on your own. Try example 2 on your own there. I'm going to freeze my screen up here, see. Okay, you should get 4/3 and negative 1/2 as your critical points. You're going to then find your second derivative. So you would, for that second derivative, you would plug in your critical points. So at 4/3, you are going to get 16 minus 5, which is greater than 0. So that means when your second derivative is positive, that means your graph is concave up. I draw it here so I don't get mixed up because it's so easy to get these backwards. So it's concave up, which means you have a minimum point right there. So you can say since f prime of 4/3 equals 0 and f double prime of 4/3 is greater than 0, f has a relative minimum at x equals 4/3. And then by similar reasoning, you'll plug in negative 1/2. You'll get a negative number here. So that means that our graph is concave down, which means we would have a maximum at that point. Okay, and you can play with the wording a little bit. It doesn't have to be exactly that, but you need to include those three pieces. Okay, questions? If you like second derivative test, you can use it for most of the problems that we've been doing so far. But if you don't care for it, you would never have to use it on a problem like number 1 or number 2. So let's look at some places where you have to use it, where you're not going to have a choice but use second derivative test. Because honestly, I didn't really teach it hardly at all whenever I began teaching this stuff, was because I didn't understand what types of questions they could give you where you would have to use it. Here is one example. This example is an implicit differentiation problem. Okay, so f is the function such that f of -1 equals 1 at each point x and y on the graph of f. That's fine. The assignment will be the same page as last night. So at each point, the slope is given by this. That's your derivative. Which of the following statements is true? So if you'll notice, relative maximum at -1, relative or minimum at -1, maximum, neither, or there's not enough information. Those are our 4 options here. So, this requires a second derivative test because we can't, like, do a sign line when there are x's and y's, right? So anytime you have implicit differentiation, you can't do a sign line because on that sign line, that's just your x-axis, right? That's just your numbers for your x. We would need an x and a y, which would be like a 2D sign line. You'd have so many possibilities to check, it just would not work, right? So, so if you have implicit differentiation, you're going to have to go the second derivative route. All of your answer choices deal with where x equals -1. So that's the point that we're concerned with. And when x equals -1, y equals 1. So if we plug that in, we've got -1 squared minus -1 times 1 plus 1 squared minus 1. So that's going to give us -1 plus 1 plus 1 minus 1. And that gives us 0. Okay, which is good, because if it gave us anything besides 0, we would have to say that there's neither a relative maximum or minimum, I think, there, because if our first derivative does not equal 0, we're not going to have a maximum or minimum point. But our first derivative does equal 0, so now we can think about the second derivative in this case. So when we take the second derivative, we'll have d squared y over dx squared equals, we will get -2x minus, what have I got to use right here for my xy? Product rule. So I'm going to have x times dy dx plus y times the derivative of x, but that's just 1, so I'm going to leave it like it is, plus 2y dy dx, and the derivative of -1 is just 0, so it goes away. Now, you could try to do some simplification here, but they've given you a point to plug in, right? So I would just go ahead and plug in the point here. So we're doing this such that x, y equals -1, 1. And so that will be -2 times -1 minus -1 times, what's dy dx at that point? It's 0, right? Because we've already found it. We plugged it in. It was 0. I should have put right here such that xy equals -1, 1. Plus y, which is 1, plus 2 times 1 times 0. so that will be positive 2 minus 1 plus 0, and that will give me a positive 1. Questions there? So, a positive second derivative tells me that my graph is concave up, and if the graph is concave up at that point, then you've got a relative minimum at that point, so A would be your answer there. Okay, so that's one example of something where you'd have to use second derivative test. You wouldn't have an option for the first derivative test. Any questions there? All right, let's look at a couple more that require second derivative test. So f is a twice differentiable function. Selected values of f prime and f double prime are shown in the table above. Which of the following statements are true? Number 1 says f has neither a relative minimum nor a relative maximum at 1. Number 2 says f has a relative maximum at 1. Number 3 says f has a relative maximum at 4. I know 1 and 2 can't be true at the same time. So if there were an option with 1 and 2, I would throw it out, but there is not. So at x equals 1, we're looking right here. For our second derivative test, the first derivative has to equal 0. Does it equal 0? Yes. So that is right there. Check. First derivative equals 0. What does our second derivative equal? Negative 2. So if our second derivative is negative, that tells me my graph is concave down. Which means what do I have at that point? Maximum. So number 1 is not true. Number 2 is true. And based on your answer choices, you could stop there, right? Because there's not another option with like 2 and 3 both being true, so it's got to be B. But let's look at 4 just to see why it would not be true. Because at 4, we still have our derivative is 0. First derivative is 0. But we have a positive second derivative. So that tells us that we're concave up, which means we're looking at a minimum point there. Okay, questions? You might be tempted to go like sine line here, but you cannot because these are just selected values. So when I say that this is like negative here and negative here, it looks like it didn't change signs, but they didn't give us all of the values, right? There could be more in between. So the second derivative is what works here. Okay? And then I think this is our last one, so let's look at it. We have a twice differentiable function. Which of the following statements are individually sufficient to conclude that x equals 2 is the location of the absolute maximum of f on the interval from -5 to 5. So that phrase right there, individually sufficient, means that it's the only information you need and you can make that conclusion. So 1 says that the first derivative of 2 is 0. Is that enough to conclude that we have an absolute maximum? No, it is not. That's not going to be enough. It makes 2 a critical point, but it does not tell us it's for sure a maximum at that point. It could be a minimum, maximum, minimum, or it could be neither at all. So F2 says x equals 2 is the only critical point for f, and f double prime is less than 0. Okay, so if we only have one critical point, which means that we're only changing direction one time, right? We're not going back and forth and back and forth. So if the second derivative is negative, what does that tell us? Concave down. You only change direction one time, so this would have to be a relative maximum, but because it's the only critical point, it's got to also be the absolute, right? So this is enough. 2 is definitely enough, but 2 and 3 is an option, so we need to check for 2 as well. So again, we've got only critical point, and it tells us f of negative 5 is less than f of 5, which is less than f of 2. Is that enough? It does not tell us anything about the second derivative, but does it have to?
It says it's the only critical point, and the endpoints are also in there.
Right.
It's the biggest.
And it's the biggest, right? So this is just not using the second derivative test. This is using the test we had learned earlier, where we find our critical points, and then we test our endpoints and our critical points, and whichever one is the highest is the absolute maximum. So this would also work as well. It's just not using the second derivative test. So D would be your answer here. It could be number 2 or 3. All right. And depending on the information they've given you, sometimes it's better to use the old test that we've had, and then sometimes there's not enough information for that, so you have to use the second derivative test. So we got about 10 minutes. This is your assignment for today from page 242. It's 41, 43, 44, 45, and 53. I want you to use second derivative test on all of those. It's possible to use first derivative test, but we just need a little practice with that second derivative test. So that'll be your assignment. You can work on, we got like 8 or 9 minutes, so you can either work on that now, or if you have questions you want to ask me from test corrections, I'll be glad to help you with those as well for that.